Candidate, sir, Sir, you can start, sir. You ask the participants to join afterwards. That's
Okay.
not a problem.
Okay.
Yeah. So first, I think first the candidate can present it. Then later we will be having discussions and question sections.
Yes, sir.
Because already late evening. So I think candidate can start presentation, and all the proceedings can happen later with the permission of university nominee. Candidate, please.
Thank you. Good evening to everyone. Welcome to this PhD online Viva-Voce presentation by D Nagaraju Research Scholar, R&D Center, Bharatiya University. University nominee, Dr. Napoleon, sir. Please welcome, sir. External examiner, Dr. Rajesh, sir. Please welcome, sir. Convener and supervisor of this Viva-Voce presentation, Dr. R.J. Ramasri, ma'am. Welcome you, ma'am. So I will start my presentation on my research topic, emotional speech synthesis system for Telugu. In present era, in this recent years, we have the human interfaces. Human interaction with the machine is an important role. They are playing an important role. So olden days, due to intelligibility, very less in intelligibility, the speech systems are very poor. At present, due to latest technologies, the speech synthesis systems are improvising, continuously improvising. So, in the area of Telugu, the South Central Dravidian language, in the state of Andhra Pradesh and Telugu, Andhra Pradesh and Telangana, it is a local language and also official language. And surrounding states, we have the Telugu speaking people are there. So, in this research presentation, we will present the emotional speech synthesis system in Telugu language. So due to growing demand in the dialogue systems as well as robotics in agents, due to dialogue systems, we will, that is a motivation to do the research work in the area of emotional speech synthesis system. The challenges should be at the starting of the research, we have the less data is available in the less research area in the Telugu emotional speech synthesis system. So our objective should be these are the objectives. Our entire research project is divided into the 5 different objectives. The first objective will be we are designed the text-to-flow algorithm. An algorithm, text-to-flow algorithm is designed. The second objective is Telugu DIFO database design. Third one is we are executing the emotional speech synthesis system for Telugu by extracting the different prosodic parameters from the speech corpus. The fourth objective is by using voice morphing algorithm implemented in the TD Pasola, we will convert a neutral speech into the emotional speech or an emotional speech into another emotional speech. Finally, we will compare the emotional speech system, comparing the asset emotion as well as the voice morphing algorithm emotion with the gold standard sets. These are the objectives. See here, based on the objectives, what is the methodology we are following? In case of the first objective, we are creating the text-to-flow algorithm. To create the text-to-flow algorithm, we are using the path tool. By using the path tool, we can extract the pitch as well as duration of the different alphabets of the different Telugu alphabets. By using the Telugu alphabets, pitch and pitch and duration, we are converting the text, input is a text, output is a profile. So by using Proth tool, we will execute this, we'll create the text to for algorithm, we'll create the text to for conversion. The second one is the diphone database creation. So in case of the diphone database creation, we have collected the speech corpus from the Linguistic Data Consortium for Indian Languages, which is at Mysore. It contains the lot of Indian languages. Databases are available. From those, we take the speech corpus. From the speech corpus, we have designed the diphone database with the number of diphones. The third one is the pitch duration as well as the prosodic parameters from a emotional speech parameter, from emotional speech corpus. We extracted the emotional parameters. These parameters can be synchronized into, they are synchronized with the asset framework. From this, we get the emotional speech. To do this task, we are using the Proth tool as well as MATLAB, as well as some of the mathematical calculations are used. Finally, emotional speech generated by TD Pasola. So that means by using the voice morphing algorithm, we are converting a neutral speech into the emotional speech, or emotional speech into one emotional speech into another emotional speech by using the MATLAB. Finally, we compared the asset emotion as well as the TD Pasola emotion by using the gold standard data set. This gold standard data set is collected from the LDCIL only. So this is the methodology what we are following. So we will continue the session with the objective by objective. So this is our basic architecture. In this basic architecture, this is the raw text we have taken. So this is the text to for algorithm. Our objective one, we are created the text to for generation, text to for conversion. This is the text to for generation. This is the Telugu diphone database. We are created the Telugu diphone database. This is our second objective. So we have extracted the emotion parameters, the emotions as well as prosodic parameters. These are all the input to our asset engine. From this asset framework, we will get the emotional profile. This emotional profile is interface with the Membrola. It is also connected with Telugu diphone database. We'll get the emotional speech. So this is the basic architecture. The first objective is text to for conversion. Second objective is database creation. Third objective is after extracting the prosodic parameters, we will execute the asset. By using the Membrola, we will get the emotional speech. See here, the number of phonetic algorithms are there. These are the existing phonetic algorithms. SoundX, as well as NYSIIS, then Daichi-Markov SoundX, Overphone. These are the existing phonetic algorithms. The existing phonetic algorithms will be majority of the existing phonetic algorithms are used for the searching of the words as well as conversion of the phonemes, representation of the phonemes. These are the existing phonetic algorithms. So now we are generated a phonetic algorithm that is the input is text, output is profile. See here, in this case, when you wanted to create a phonetic algorithm, we'll take the alphabets. We'll take the alphabets of the Telugu. So from the Proth tool, we extracted the pitch as well as duration. In case of the duration as well as pitch, in this text to for conversion, we consider the pitch at exactly at 50% of the wave. So in this program, we are taking the 56 alphabets in Telugu language. all 56 alphabets included with the space, we are included. So this is the, so when you wanted to collect the duration as well as the picture duration of the speech, we are collected the speech corpus from the Linguistic Data Consortium for Indian Languages. Already I said that this LDCIL is the, it have a lot of resources in Indian for all Indian languages. Majority of it is organized by the government of India. So on free and open source, they are all the open source. After registering ourselves, they will provide the database. So from this Telugu speech corpus, what we are taken from the LDCIL, we have the 2480 sentences are available in the database. From this 2480 sentences, we are using the, for this research work, we are using the 106 sentences or 622 words are taken from the, to get the duration as well as the pitch as well as the duration of the all Telugu alphabets. See here, a text to for conversion, input of the input is the text, output is the for. For is in this format. The for file is the, this is the label as well as duration of the duration in millisecond. And at 15th position, what is the frequency? So here it will use the, see here, this statement can use the synthesizer. U is a phoneme. It produces the 129 milliseconds or milliseconds duration. Its pitch at 50% position. At 50% position is 156 Hz pitch, 129 millisecond duration. See here, this is the how we are extracted the pitch as well as duration from the Proth tool. So once we open a Proth tool, so when we are click on the view as well as view and edit button, see here, now we are creating the annotation file for the to separate the alphabets in the given speech corpus. We are using the annotation file. After the annotation, see here, now this a word can be separated like this. So from this, we will separate the phones. Phones are separated in Proth tool. So after separation of the Proth tool, we are extracted the 56 alphabets, their duration as well as pitch as well as duration. From these 56 alphabets, for this to get the 56 alphabets, we are using the 116 sentences. So this is the total duration as well as frequency at 50 position, at exact mid position of the so these are the values we are getting. Then it is a phoneme table. In case of the asset, we can connect with the different type of alphabets, where it is a long vowels, short vowels, as well as voiced, plosives, unvoiced, unspirited, and aspirated voice to all 56 alphabets can be so interconnected with the asset by using the XML format. See here, this is a sample file, sample 4 file. This is the label. This is the duration of the particular label, position 15%, and F is frequency. So in this case, we have the possibility to extend the 25%, 75%. Like this, we can divide the number of positions So when the positions will be increased, if the number of values will be increased, automatically the efficiency of the FO file is also increases. In this research, we are using the 50% is the frequency. So this is an example we are getting from the our text to for algorithm. So there is a word, there is a sentence. This is a word, a sentence in Telugu. It is from our text to our TTE text to for algorithm generates these values. So this is the programming for to execute the text to for format. So this is the object 1, text to for file conversion. Text input is text, output is the FO file. The FO file is an input to the FO file is input to the our asset framework. So then the second one is second objective is the diphone database creation. So in existing, lot of diphone databases are there in different languages. In different languages, we have the different diphones. See here. So when you wanted to create the Telugu diphone database, the stages are the first we have to know the list of phones as well as diphones, collection of wave files, or we can record the wave files, extraction of the diphones from the speech corpus. Finally, we can equalize the diphones to create the diphone database. So these are the 4 different stages. So in case of the first stage, see here, Telugu alphabets, we have the 56 Telugu alphabets. Among these 56 alphabets, the phones are 26 phones are available. The remaining, many of the alphabets in Telugu, they are the combination of 2 or more phones. So in case of the phone list, vowels are the 5 vowels, consonants are the 21 consonants. Total phones are 26 plus 1 pass. Why means during the diphone database, diphone generation, we can take the first one is empty with the phone, and also phone with empty. So we can use, you can add the pass also, pass. So that is a 27. Among the 27, the total diphones possible, in diphone database is n square minus 1. So n square is minus 1 means, so all 26 phones can create both sides, can create say before the phone and after the phone in a pass. But in case of the pass, it does not require the after or before pass. So that's why 1 is less. So there is a 728 diphones are present as per our research work. So total phones are the total alphabets are 56, phones are 26. So diphones are the 728. So when you wanted to create these diphones, when you wanted to collect the diphones, or when you wanted to extract the diphones, we will get the wave files from the IIT Chennai. So from IIT Chennai, we can take the male mono diphone database, It contains the 2480 sentences are available from this for both the text to for as well as database creations. We are using the 106 sentences. 106 sentences. In 106 sentences, 622 words are there. So we are extracted the 728 diphones from this speech corpus. So the things will be the by using the diphone by using the path tool, we will extract the diphones. So diphone means first half is one phone, second half is the another phone, the combining of one phone, mid of one phone to the midpoint of the second phone of a consecutive diphones, you may call it as a diphones. So this is the architecture, how a diphone can be extracted and how a diphone can be decided. So there is a speech file. From these speech wave files, we can make the annotation file by using Path tool. So we can extract. After extraction, we can make the segmented file. We can make the segment file generation. From the segment file generation, included with the all diphones, we can get the diphone database. See here, it is a similar to what we are using in TTP, text to phone conversion. The same Path tool, we have to read the Path tool and view, as well as we can see here. This is we created the. So there is annotation file. In this annotation, there is a word in first line. The second line will be, we can separate the diphones by using the quality sound mechanism. We can separate the phones. After separation of the phones, we can separate the diphones. We can separate the diphones. These diphones are extracted as a wave file from the Path tool. Now we can get the text grid as a text file. Text grid means it gives the starting position of the phone as well as ending position of the starting position of the diphone as well as ending position of the diphone. So it's a text to grid text file is created. So this is the sample for the text grid file. So it shows that. So this YA is the diphone. It starts with the 0th position and end at the 0.22375 seconds duration. Then interval size is 10. So this is like this. The text sample text grid file. This is sample text grid file. It is converted to the 4-file conversion. Path text grid to the Membrana. From this online website, we are converting this text grid file into the 4-file format. So this is also a membrolator. It converts by using the speech corpus, by using the diphones, as well as by using the text grid values. It may convert the diphone database. So the membrolator can convert this diphone database. In this diphone database, the minimum requirements of the creation of diphone database is 16 kilohertz. The maximum possibility by the membrolator can create the 1000 samples only. If more than 1000 diphones, the membrolator cannot create. See here, this is our database created on August 18, 2013. This is the Telugu diphone database. It is created 18th 2013. So this is the database size. So what are the common mistakes took place in the diphone database creation? Common mistakes are the mislabeling, mispronunciation of the phones, wrong position of the pitch marks. So this should be avoided. Mislabeling can be avoided after testing every diphone. After testing every diphone, if there is any mislabeling is there, we have to change the labeling. If there is a mispronunciation, the pronunciation will be changed. We have to re-extract the diphone. If there is a wrong position of the pitch marks, again we can go for Path tool. Again we can go for the Path tool, and we have to select the pitch marking. So this is the objective to diphone database creation. Then extraction of the emotional parameter. So the third objective is the creation of the emotional speech creation by using the ESST. So emotional expressive speech can done by the explicit control, playback approach, as well as implicit control. So explicit control means the prosodic parameter can be changed based on the externally. The prosodic parameters are varied externally. If there is varied externally, that should be emotional speech will be generated. If it is a playback means a large database, the large emotional database is created from the large created emotional database. We can extract the emotional expressive speech implicit control. Expressive speech synthesis by implicit control means the prosodic parameter internally we have to change. So from this, the first one is explicitly control. Our asset, ESST, asset can be executed on the based on the explicit control. Our voice morphing algorithm is based on the implicit control. These two emotional speech synthesis systems are there. One is explicit control. The voice morphing algorithm is based on the implicit control. So the definitions of the happy, sad, as well as angry. So in this, a lot of emotions are there. Among these, in this research study, we used the happy, sad, as well as angry. These three emotions are taken place. So a pleasant state, a human, the emotional state of a human being is in a pleasant state is a happy, is a unhappy state is a sadness, is a strong resentment, feeling of wrong resentment is an angry. See here, so these are the some of the existing explicitly controlled. These are the existing one based on the different type of speech synthesis. This is the permanent speech synthesis. Now it is a diphone based existing explicitly controlled. Explicitly controlled by the playback means based on the large database, largely emotional database it was going to create. Then implicit approach, HHM based models are implicit approach. Our TD Pasola is also implicit approach. So when you wanted to get asset, that means the prosodic parameters can be extracted from the thing. So we can use the pitch, average rate, as well as contour, intensity, duration. These are the prosodic parameters we are using to make the emotional speech. So these are the already existing expressions. Some of the scientists, they are doing the research in the area and they are doing the research work. It is also the similar thing. Studies on excitation parameter. Study on excitation parameter means analyzing the subsequential or segmental levels. That means that is divided into the number of parts. Signal can be divided into some of parts. Then we are going to see the variation. So generally, jitter as well as shimmer are the examples for the excitation parameters. So on the basis, we are using some more emotional speech synthesis systems. So now the collection of the expressive data. How we are collecting the expressive data? Expressive speech corpus can be collected either simulated by the actor or by the data collected from the real life scenario. From the real life scenario, we may collect the expressive data, or from an actor. An actor can simulate. So both the cases, we have the different scientists. They are doing their research work in both areas. It is also similar to the same information. See here, this is our proposed work, our proposed asset for Telugu. So in this, it is a explicitly controlled prosodic approaches. So in this case, we are using the pitch, range, pitch variability, pitch contour, last syllable contour, speech rate, phonation, articulation. These are the parameters we are using to get to extract the emotional parameters. So then we can implement it into the emotional speech synthesis system. So emotional speech corpus we are getting from the IIT Kharagpur. Respected K Srinivasa Rao is professor from IIT Kharagpur. From him, we are collected the emotional speech corpus of the three different emotional languages. So this is the web link for the to download the data. So in this data, we have the same sentences. 1,489 sentences are in different emotions. The same sentences are different emotions are there. So our requirement is happy, sad, and angry. We are collected the speech corpus from the IIT Kharagpur. So in this asset generation, we are using the different variables. What is the methodology we are using? When you wanted to get the pitch, we by using the autocorrelation program. Autocorrelation program, it is implemented in the MATLAB. We are extracted the pitch value, and also the pitch range is the maximum or minimum of the font. From the froth tool, we are extracted, and the pitch variability and pitch variability can be extracted by the incorporated by the pitch variability by using the formula. By using the mathematical calculation, we get the pitch variability. Pitch contour is again by using the autocorrelation method. We are implemented in MATLAB. Last syllable contour. So based on the curve, when we are seeing on froth tool, based on the curve, we can decide what is the last syllable contour. Speech rate is the number of words per unit. So how many number of words are there? Based on that, the speech rate will be decided, as well as jitter. Jitter can use the variation of the frequency, variation of the pitch in a regular intervals of time. Then, so these are the common variations in the prosodic parameters. So based on the different variables, different prosodic parameters. So based on the different emotions, so how they, which one is least, which one is high. This is the comparison of the different emotions with prosodic parameters. So see here, this is the MATLAB program for to get the fundamental frequency or pitch from the MATLAB. This is the autocorrelation. So this is the, now here it is the NW means is a neutral voice. So you can use different voices from the sentence. We will get the pitch. So almost 25 sentences are taken. From the 25 sentences, we can extract the fundamental frequency. After average of the fundamental frequency, we may decide the fundamental frequency of the particular wave. So based on the fundamental frequency, so different emotions will have the fundamental frequency of this. So from this is the analysis of the analyzation of the variation of the fundamental frequency of the pitch. So the pitch range is the span between the lowest to highest pitch. So if you wanted to change the pitch range, we can make the air pressure. Air pressure can changes the pitch range. Vocal cord coordination also changes. Vocal resonance also changes. So like this, we have the pitch range will be calculated by using the froth tool. So after 25, we are considering the 25 emotional speech synthesis, emotional speech corpus. Based on that, we can take an average value, and also we may consider what is the pitch range rate of the pitch range. So for including neutral, remaining 3 emotions. Then pitch variability. So the pitch variability means pitch variability of variability correlation of the pitch or variation of the pitch in the equal intervals of time. So if it is so in case of the pitch variability, we are calculated by using the coefficient of variation by mean. Coefficient of variation by the mean. So mean and standard deviation. Standard deviation by mean, we may calculate the pitch variability. So for the purpose of calculating the pitch variability, we are using a program to execute. So the total signal can be divided into the number of equal parts. So each equal in equal intervals of time, we can get the frequency from every interval. We'll calculate we'll take the frequencies for each and every interval. Then we can calculate the pitch variability by using the standard deviation by the mean. These are the calculations for the sample calculation for the pitch variability for different emotions. This is the consolidated. Then we can calculate the rate of pitch variability. So there is a pitch contour. Pitch contour means how the curve can tracks, how a signal can tracks. So this can be calculated by using the fundamental two frequencies by the number of intervals. So frequency F1 is the highest frequency, F2 is the lowest frequency. Between these two, how many number of intervals are there? The entire speech signal, how many number when we are divided, that should be, we'll get the pitch contour. So the pitch contour is a mathematical calculation. By using the MATLAB program also, we can get the pitch variable. So this is the program for the MATLAB program to get the pitch variability. So this is the sample calculations for the pitch variability and also the pitch contour percentages. These are the pitch contour focusing. At final stage, what is the focusing of curve can traces. So if it is angry, it is in falling condition, sad and happy is in rising condition, if it is a neutral, is in flattened condition. So there is a last syllable. Last syllable should be we are getting the last syllable from based on the path tool. From these diagrams, we can clear the last syllable will be where it is in decline or up mode or here the duration of the thing. You can get the some more analysis based on the frequency duration, speech rate. So the number of words per minute, number of words spoken per minute, we call it as a speech rate. So there is a slow speech, 110 words per minute. If it is a moderate, 150 to 200 words per minute. So generally the book reading like this, 150 to 160. Auctioneers or commenters can use the 250 to 400 words per minute. So the speech rate is dependent upon the state of emotion of the human being. So these are the normal. If the nervous and the stress is also changes the speech rate. Mental fatigue also changes. Complexity of the words are also changes. So these are the parameters. They can affect the speech rate. So some of the example calculation for the speaking rate for a single word, for a single sentence, we are calculating. Then phonation, there is a jitter, there is a deviation of the pitchy parameters. So we can calculate the F0 contour, and in different levels we calculate the frequency, fundamental frequency or pitch changes in the equal intervals of time. So by using this formula, we can calculate the jitter. So these are the sample calculations for the jitter. Then articulation. Articulation means synchronization of the different organs in the during the speeches, during the speech sound. So they are the tongues, lips, jaw, some other. So see here. So when I wanted to execute our asset, we are using the 3 different configuration files: the configuration file, language specification, and also the emotional specifications. The software requirements are the Java 1.5 above. We will run the asset in Sigma environment. So we can use the MATLAB for calculation. What are the tools we are using? We are using the path tool as well as Memrola to get the emotional speech. So see here, this is the text for the input of the text. Then there is a raw text. The input of the output of the profile. This is the profile formation. It is an input to the asset. So by using the Java in a SQL environment, by using the Java -jar ESST asset jar use UUI. So by using this command, we can open the asset frame format. So in this asset frame format, the prosodic parameters already in emotional file we are prosodic parameters in emotional file we are included. So there is if you are selecting the emotion, after selecting emotion, we'll give the input profile. We are loading the profile. So once we are loading the profile, then we'll select the emotion. Then we can click on play. We'll get a happy emotion. Like this. This is the profile for the memorial output file for the happy emotion. Like this, we can select the same text, the same profile. We can use the sad emotion selection as well as angry emotion selection. So by using the asset, we will create the happy, sad as well as angry emotions. So this is the asset execution. The fourth objective should be our fourth objective is creating the emotional speech by using the voice morphing algorithm. So in this case, we will take by using the 2D persona, we can execute this. In this case, we'll take a source, a neutral file. In neutral, you can take a neutral voice, and we have a target. What emotion when you need? You need an emotion. For example, when you wanted to convert a neutral voice into the happy voice, first we have to take during the designing, we have to take the neutral as well as happy, same sentences. From this, we can extract the prosodic parameter, both neutral as well as emotional speech. Prosodic parameters can be extracted, pitch as well as duration. Both the values can be extracted by using the path tool. In this case, once you can we'll take the neutral file, is the input file. We'll change the time scale as well as the pitch scale. So time scale can convert the variation of the duration. Pitch scale can convert the pitch of the wave. So by changing this time scale as well as pitch, we can change the emotion. We will convert into the neutral into the emotion. So in this case, see here, if there is an alpha, there is a variations, 3 different variations. When the duration was going to increase, that means alpha here, alpha we may call it as alpha. Alpha is greater than 1. Greater than 1 means time duration is more. If the time duration is more, we can make the more duplicated frames. If the time duration is less, we can discard the sum of the frames. If there is equal to 1, no need to change the frames. Beta is the fundamental frequency variation. So after processing the number of repeated times, we will get the emotional speech. See here. So for this, we are using the TD Pasola to create this. So this is the input speech. There is a pitch estimation or pitch marks location. We can vary the pitch scale as well as time scale. The finally TD Pasola can convert a neutral speech into emotional speech, or an emotional speech, one emotional speech into another emotional speech. See here. So initially you can take the four different emotions included with the neutral voice. We are extracting the pitch as well as duration of those pitch as well as duration of those 4 emotions including neutral. See here, first we have to convert a neutral voice into happy voice. So we take the happy voice, the pitch as well as the time duration. From the path through we can get. Then by using the TD Pasola can be implemented in MATLAB. So there is you can take the neutral voice. This is the neutral voice. This is the pitch as well as duration. We are trying to change the pitch into the up to 245, time into the up to 3.08. We can make the near to the pitch as well as duration will be changed. Automatically, the emotion is also changes. So like this, we can take the number of iterations. We can make the number of iterations in these iterations, we are using the, so based on the output value, when you wanted to increase or decrease the alpha as well as beta values, there is a number of iterations. After a few iterations, we'll reach the pitch value is near to the happy signal, and also the duration is also near to the nearly equal to the happy signal. So that means this neutral voice is converted by implicitly we are changing the pitch as well as duration. This is the happy to neutral. So these are the signals what we are extracting by using the Proth tool. By using the Proth tool, we have to extract this. So sad and neutral signal to sad emotion, as well as neutral signal to angry emotion. So this is the for pitch marking. When you wanted to pitch marking battle program to execute this, then there is a Pasola as well as TD Pasola. These two programs are used. These two are in MATLAB programs. We are using the change the alpha as well as beta. See here, alpha and beta, these two are the parameters. So alpha equal 1.4, beta equal 0.8. That means we are changing the alpha and beta. We can, the input is the neutral file. We are continuously changing. So every changing of the alpha and beta, the wave file will be generated from the MATLAB. That is, pitch as well as duration can be calculated, can be extracted from the Proth tool. So by using this TD Pasola connecting with the TD Pasola, we can get the emotion speech. So finally, the last one is the we can make the testing. So the quality, accurateness as well as reliability can be dependent on the testing only. So in this case, we are using the 25 listeners to take it to the testing situation. We are considering the 60% is the threshold value in this research purpose. So in this, we are calculated the effort required. We are given the different criteria, different points. If it is there is no effort to, there is a complete relaxation possible. That means no effort to identify the emotion. We will give the 5 points. There is no considerable effort. There is attention is required, no considerable effort, we will give the 4 points. If there is a moderate effort is required, 3. If there is a more effort is required, we will use the 2. There is no emotion, we will give it as a 1. Based on this review, and also we will take the 25 participants in the test. We can take the different categories. So from this, we are calculating the perception test as well as effort rating. So we are executed the asset as well as TD Pasola. We are compare this perception test as well as effort rating in this case. And also there is an acceptance test. Acceptance test means out of 25 members, how many members they are accepted that emotion, how many members they are not accepted. So this is the acceptance test, percentage of the acceptance by the 25%. And also we are compare the analytical comparison between the speech signals against the gold standard data signal. So this gold standard Telugu raw text corpus also we can get from the IDCL. From the IDCL database, there is a gold standard Telugu speech corpus is there. We compare we will take the one sentence from the gold standard raw text. The same will be executed by the voice morph algorithm as well as the SH speech signal. So this is the actual parameters of the different parameters, pitch range as well as variability, contour, speech race, and jitter. These are the different values for the original gold standard corpus. So by using the voice morph algorithm, we will get these values. By using the asset, we will get these values we are getting from the asset. So similarly, it is for happy emotion, it is for the sad emotion, as well as it is for the angry emotion. So in this case, when compared to the gold standard, voice morphing algorithm, compared to the voice morphing algorithm, SH speech have the a little bit higher, but it may not be accurate to the gold standard. So in case of the speech corpus, it is not easy to get the accurate. So there is a minor variations. That means 80 to 90% we can make the effort. So what is the future work from this? See here in text-to-flow algorithm, our first objective text-to-flow algorithm, I consider only the pitch value at 25 or 50th position. That means at mid position, at exact mid position, it is possible to extend the pitch 25 and as well as 75 position, and also some more different equal individuals positions also. Then automatically improves the efficiency of the profile. So we are created a 728 diphone databases, diphones. During the synchronization by the Memrola, few of the diphones are not working properly. So when you wanted to abrogate the diphones by adding the those diphones, and also the prosodic parameters, few prosodic parameters are taken. Some more parameters are there, stress, tempo, etc. It is possible to add in the asset in future. In case of the Telugu pronunciation, different areas like Rayalaseema, Telangana, Godavari, and Srikakulam districts, their slang will be different. So if their slang will be different, automatically their parameters are also changes. So above all are the sources for the future research work within the area of the emotional ETS engine. So some of the publications. Thank you one and all for your patience listening. Thank you, sir.
Sir,
Any questions from outside experts? Napoleon, sir?
sir, no, sir. If you have, sir, you can ask, sir.
Okay. So from audience, any questions? After that, I will have some questions. From participants, audience and other experts in the panel. Okay, if there is no questions,
You can ask, sir.
Yeah. So throughout the presentation, it was a very good presentation, and I appreciate the effort.
Thank you, sir.
But I think I was not able to see your face. Actually, head portion is able to give camera.
Sir.
Yeah. Okay, good.
Thank you.
So first of all, I would like to appreciate at this age group, you have taken initiative to do a PhD. And also appreciate the guide in guiding you in getting a PhD degree at the nearing to retirement stage, I think. Very nice work we have done. But a few questions from my side that may help you to trigger you also, if possible, some more research and other support in the area of this NLP. Throughout the work, whatever I see, there was systematic workflow that you have presented. But really what I feel is your real contribution actually comes in the fourth one, right? Other places, I think you have used that PRAT tool to extract something and try to do some thing. There is no automation, I think, in that particular first three contributions, right? Is it right?
Yeah. Sir, actually, the PRAT tool is the major phonetic based thing, sir.
I know, sir. We have worked on that. I know that. But as far as I concern, there is no automation actually done in that part. You have done some research, but I don't feel any automation. The real contribution that I feel is in the last contribution, in which you do some conversion of normal thing and have something, right? And I like to hear at least one sound, a normal sound that you have made in the PPT also, but you have not played it. What normal sound, and after happiness, how it look like after sadness. If you have, just play for us. We want to just listen to it. That's all.
Sir, I connected with laptop, sir.
Okay.
The data is in my my
Because
CA.
you the entire research work you concluded with like that you have a set of listeners,
Yes.
25 set of listeners, and those listeners are judging. We are also judging people. We have to see actually how the difference in normal voice, how it is becoming happy, how it is becoming sad, how it is becoming angry, and all these things. Okay, anyway, you are not having. Then one more question that I am having is, wherever you say that you have taken database from others, for example, one of the database that you told having 1489 records,
Yes,
you say that you are only taking 50. Can
yes,
you
sir,
justify why?
Sir, sir. So out of 50, 50 sentences, our required diphones are extracted. Diphones as well as phones are extracted. That's why only we are taking 622 words are. That's it.
In another case also, you are talking about 2480, in
80,
which
yes.
you are only 106
Yes,
you
sir.
have taken.
Yes, sir. Yes.
So those places, why you have not generalized to consider all the, because the number of records, if I see based on our research experience, we say that it's all very small thing. 1400 is nothing big, and similarly 2480 is also not big. You should have taken all the things, so generalize whatever you say. Then during the listeners, what is the age group of the listeners that you have taken?
Sir, for 25 people, sir.
Yeah.
So 5 persons retired.
Okay.
5 person from 50 to 60 age.
Okay.
5 person from 18 to 20 student age.
Okay.
Like this, different ages we are.
Okay. So whether any linguistic experts are available in that group?
So linguistic experts means
because they will be knowing the actual emotional stage much better than a normal layperson. Suppose I am in my state, I am speaking some Malayalam or Tamil or something like that.
Yes,
if I hear it, if I am not a native speaker, I may not be able to a good judge for that. So if you have a phonetic expert or linguistic teacher or as an NLP based expert, then that is why I asked whether somebody is there in that particular team, 25 team, whether you have such type of experts. You have not included, right?
No, sir.
Yeah. Okay. Then one more question I was having, that is normally different judges will have different opinions, right?
Yes, sir.
How will you match that opinion? Whether you do some t-test, other type of testing. There are several testing that we do.
Yes,
when you have something called human opinions. Okay,
yes,
when you have human opinions and also you grade it into different levels,
yes,
right? How much they recognize, how much they not recognize, how much effort they took. When you have such type of grading and also having different experts, like 25 experts, how will you consolidate it? Do you have any type of testing and say that the p-value is less than something, so that we agree that this is exactly having something?
So based on 60% agreement, we may consider such threshold value 60%.
But you have to do, actually, as per research, you have to do, whenever you involve a human being as a human judge, you need to have some testing, and you have to say that this much based on this particular testing, you prove that it is good or bad. Okay, so that's what I felt that's missing. And another thing is, whatever methodology that you follow, whether it is applicable to other languages.
It is applicable, sir. With minor modifications, we are ready to apply.
Yeah. So why you have not made a small comparison about your method with already good existing some other existing languages, and made a comparison at least? For example, a standard database. This database is within Indian database. It will be very difficult for other people to compare. Even Telugu, those who are not knowing, will not be able to compare. Some other standard database which is known to the world, if you take it and try to compare with your method, that comparison table might have improved actually your research. Anyway, you have done nice work. It's not an issue. Then the comparison part also, that is what I felt a little bit that vagueness there. The comparison was so strong, not so strong. So that okay. Otherwise, you have done pains in this particular age, right? At this age of retirement, you have taken pains, and guide also has taken pains to guide you and make you as okay. Then as part of the publication, I was just can you show me the list of publication that you have done? Yeah. Okay. 1 minute. So anyone in Scopus or
Sir, two are in Scopus, sir.
okay. Okay. I think you need a little bit more effort. Definitely your work, if you try to compare, it can come in very good science citation index journals, because the work that you have done is very good, but I think you have not taken effort to include some good type of comparison, and maybe certain time of fear that you whether the international journal will reject or something like that. But you should have tried it and improve it, and still possible after PhD also.
Okay.
Because it's a special language in which you are taking and trying to do the efforts on that. And for that language, if somebody has done internationally, definitely there are higher chances of getting in SCI. So always try to do that thing, even after PhD also. I think PhD also you get. And for the young scholars who will be listening to this Viva-Voce, I like to ask one more question. What are the difficulties that face during their PhD? Real difficulty in research, not in other aspects. So others will also understand, because 1 or 2 sentences you can say, so that will motivate the young research scholars who are available.
So in the area of Telugu emotional speech, we have a lack of research in the area of Telugu, sir. Why means in Andhra Pradesh, majority of the universities, they may not consider the NLP as an individual subject. They are making it an optional subject. So the majority of the students, they can go for they can make the alternative subjects. They are not selecting they are not studying the natural language processing. So from last 4 to 5 years, that may be changed. So that's why that is the difficulty what we are facing.
Okay. Napoleon, sir.
Sir,
shall we conclude it?
Yes, sir. You can conclude, sir.
Yeah.
Okay.
So with the permission of the guide and also the university nominee Napoleon, sir, based on the publication of the candidate, based on the research work done by the candidate, and based on the research presentation done by the candidate, I recommend the university authorities for the award of PhD degree to the candidate, and now onwards the candidate will be called as Dr. Nagaraju, and I wish all the best to the candidate as well as the guide for the successful completion of the PhD.
Thank you, sir. Thank you, sir.
Sir, I thank both the external examiner as well as the university nominee for your kind cooperation in completion of this Viva. Thanks a lot, sir.
Thank you, sir. Napoleon, sir.
Thank you, sir. Congrats, sir.
Thank you, sir.
Congrats, Dr. Sir.
Thank you, sir. Dr. Rajesh, sir.
Yes.
So, thank you very much, ma'am. Ramasri, ma'am, thank you very much for your kind cooperation, even though you are in a foreign country. Thank you, ma'am.
So Napoleon, sir, Ramasri, madam, and Dr. Nagaraj, sir. Actually, I want to leave it. Too late. I have to move home.
Okay.
I'm in office only.
Okay.
So
Thanks a lot, sir.
Yeah. So I'm just leaving it.
Okay. Thank you.
Yes, sir.
Napoleon,
I am
sir.
also, sir.
Napoleon, sir. Bye.
Yes, sir. Bye, sir. See you later, sir. See you later, sir.
Bye.
Thank you.
Thank you.
Ramasri, madam, and the candidate.
Thank you, sir.
Thank you.
Napoleon, sir, what is the next step, sir?
Madam, you can send the report, madam. I will send the report to the R&D, madam.
Okay.
I will send it, madam. As far as myself is concerned, I will send it. So you can send the report directly to the R&D.
Okay, sir. Thanks
Your
a lot.
report.
Sir.
Yes,
Thanks,
madam.
sir.
Yes. Ask the
Yeah.
candidate to send the title as well as how many number of participants.
Okay, there
attended
is
to-
a checklist, and I'll even though
Yeah,
I am
number is okay. Number is okay, madam. 30, 35, just like that. That is okay.
okay.
And also
Thank
title
you.
of the thesis, because I have to note it down, right?
Okay.
Thank you, ma'am.
Thanks,
Thank you.
sir.
Thank you, sir. Thank you, sir, for your nice and excellent presentation, sir. Thank you,
sir.
doctor.
Thank you, sir.
Okay, sir. Okay.
Thank you, ma'am.
నాగరాజు జూమ్
Madam.
మీటింగ్ లో మాట్లాడు తర్వాత వేరే దాన్ని.
Madam. Okay, thank you very much for participants. Those who are participated, thank you very much for your patience listening. Thank you, sir, for your patience listening. After a number of breaks from morning to evening, finally we conclude at 7 o'clock. The participants are also waiting from morning to evening. So finally we concluded. Thank you, one and all.